Hello everyone. So welcome to our second workshop of ICP Codefest. So I will just yes, Francis, you can just start with the workshop.
Okay. Hi, everyone. Good to see everyone again. Good evening, good afternoon, and good mornings. May I know how many of you here attended the previous workshop? Maybe you can leave a message like put in 111 so that I know whether how many of you already attended the first workshop. Okay. Yeah, I would like to know, is it most already attended or most is not attended? If most not attended, I shall repeat again the previous what you need to prepare the installation for a bit. Then later I will start the talk about the chain fusion technology, how you use ICP smart contract to call the Ethereum network smart contract. Okay, I just see three only attended the first workshop. Okay, don't worry. For those who never attended, I will start from beginning. Okay, can you all see my screen sharing? Please put Y if you see the presentation slide. Okay, thanks. Okay, let's start. So how many of you know has been doing some development with ICP, or this is your first time to learn about ICP's developments? For those who is the first time, let's start. Actually, this is a prerequisites that you need to prepare before you able to do any developments. Okay, this is the slide. Okay. So what you need, if you are using Windows, ICP development tools SDK all required Linux environment. That means you need to have a Linux environment in your operating system. If you are using Windows, you need to install a Windows subsystem Linux. Then install the Linux distro, example like Ubuntu. So that you able to install the ICP SDK, because ICP SDK only support Linux or Mac OS. So this is a step. For Mac user, you can skip this step. So you can get my slide. Actually, you can get this slide also in the Telegram groups. So this is some of the steps you need to go through. Once you have your Ubuntu in your Windows operating system, or another alternative option, you can use something like VirtualBox, Windows VirtualBox, Oracle VirtualBox, or VMware Player to install the Linux in the virtualization tools. Also can. So when you have that, next, you need to install Node.js. You need to install Node.js in your Linux, in your Ubuntu Linux. You must enable. So once you complete this step, that means you already have Node.js installed. Because some of the during when you do the developments for front-end web, you will need to use Node.js to build your front-end applications. And then this is the important step. This step is required because you need to execute this to do the install ICP SDK tools in your Linux by running the shell command. So right now, if you have your laptop with you, you can try the installation. You can try the installations by running this shell command. Once success install, whenever you type dfx space dash version, you should see the version return. Okay. So after you install the ICP SDK, and another one is, since ICP is using Motoko programming by default to develop the smart contract, like Ethereum's, normally we use Solidity. In ICP, we use Motoko programming language. It's also similar like JavaScript. You need this so that because there's a lot of package, Motoko package, the ready package for the Motoko smart contract. You need this package manager to provide you the extra package when you do the developments. Come into this. Some of your laptop, if your Windows update is not to the latest, or maybe your laptop, some of the BIOS, example, virtualization technology flag is not enabled, you may encounter failure to do the Windows subsystem installation. If you try your best, still cannot do the installations, I do prepare you another alternative way whereby you can click this link, click to the Gitpod link. It will create a virtual machines running under Gitpod and automate install all the necessary tools so that you can do some practice without install any of the ICP SDK in your local device. But my recommendation, you still try your best to do the installation, because later on you may need to use the command line to create your ICP developer account or ICP wallet, which the public and private key pair is going to store in your local device. If you're using this method, the key pair will store in the Gitpod virtual machine. Whenever it idle, it will delete the virtual machine. If you forget to back up the private key, you may lose the account forever. So ICP developer account, or you can say this is an ICP wallet. Same like others blockchain, like Ethereum, Bitcoin, all these. The wallet is derived from a private and public key pair. So when you generate, later I'll show you the command to generate your developer account. Once you generate your developer account, it will return you a seed phrase, a 24-word seed phrase, which represent your private key. As in ICP account, normally we don't say wallet address. Accounts are identified by principal ID. In ICP account has two types of ID. One is called principal ID. Second is called account ID. The difference of principal ID and account ID actually is used to receive ICP token. Principal ID is used to represent the ownership of the canister or ownership of the smart contract. This is slightly a bit different compared to Ethereum, smart contract, whereby ownership is always the wallet address. In ICP, ownership of the smart contract or canister is derived from principal ID. And if you want to receive ICP token, you must use account ID. So try not to mix up. So once you have the ICP SDK tools installed and you check your command line and DFX already enabled, to create an account, you just type DFX identity new. Then your label of your identity. Whenever you success one, you new, it will ask you to type the password. Remember the password, because this password is going to use to encrypt your private key. If you forgot the password, the only option you need to restore back by using the 24 words of account seed phrase. Once you enter the password, the terminal will return you the 24 words seed phrase. Please backup it. Please backup it. Because if you lost it, no one will able to help you to recover. After you create your first account, how do you get your principal ID? So this is a command line. This is a command line, get principal. Identity, get principal. It will return something like that. So this is your principal ID. You're also able to create multiple identity or multiple account in your device. To change or switch identity or account, you can use this. DFX identity use, change different account. This is another function for you to retrieve account ID. Retrieve account ID. DFX ledger account dash ID. Account ID will look like this without the dash in between. Always remember, principal ID has dash in between. So account ID don't have. Always remember, this account ID is used to receive your ICP token or ICP coin, not principal ID. But if you want to receive those non-native token, example, the token created by using smart contract, then you will use principal ID to receive, because it's related to smart contract or canister. Account ID only receive ICP coin, which is a native token in ICP blockchain. Okay, if you follow, if you come back, so this one, if you have forked my code, if you have forked my sample code, you can go into my sample code, you can enter your edit and enter your principal ID and ledger ID as a first step and commit it. So later on, maybe I can drop you some free cycle, which is the credit for pay the gas fee. So this is a slide. This another slide is import account. So this is how you recover your account in case you change to different machine or different device. Then you can use this command to import back your 24 words of seed phrase. You just paste your 24 words of seed phrase into a text file. Then run this, point to the text file. Then it will recover back your account. Other than that, to check your account, ICP token balance. So in ICP, same do like other blockchain, which has mainnet, like Ethereum mainnet, it has mainnet, it has testnet like Sepolia, Polsky, and it also has local network, which you run a blockchain in your device. But for ICP, it doesn't have testnet. It only has mainnet and local network. It doesn't, compare to Ethereum, it has testnet, but ICP doesn't have testnet. So to connect, when you want to deploy your smart contract or you want to check your account balance to mainnet, you need to insert this parameter or another shortcut form of parameter. This tells the command line to connect to ICP mainnet. Without this parameter, actually you are connect to your local network. Later, I will show you how you run your local ICP blockchain in your device for development purpose. Without this, you are telling the command line connect to local network. For ICP, just now, all the dApps to create account is for developer or programmer. When they want to build, when you want to build application, you need to use the dApps to create your developer account to deploy your smart contract and do your programming stuff. For end user, when you build application, you want the end user to use your dApp decentralized application, Web3 application. For them to create account, they won't use that method because it is too complicated. For end user, you should integrate your application with, first, you can choose internet identity. Internet identity is a web single sign-on by using passkey. It means when you create ICP account by using internet identity, it works like how you create account for your Google account, Facebook account, but without using password. They are using passkey technology. Another method is install the Plug wallet. Plug wallet work like MetaMask. So it has a browser extension and mobile app to create the ICP account or wallet. Later, I also have an example for you how you create your own self-custody wallet. So this is how internet identity works. So when you visit internet identity website, you just click internet identity. It prompt up, you can choose where you want to store the passkey. So you can choose your same window machine, or you can choose your phone to store the passkey. If you choose other device, then it will prompt you, it will show you a QR code. It will show you a QR code. Then you need to use your phone to scan the QR code and make sure your laptop and your phone Bluetooth is turned on. At that moment, there will be some synchronized process. After that, the passkey will store in your phone and go through a flow success. You will get the internet identity ID. This internet identity ID is not your principal ID or your account ID. So you need to use another method to retrieve this internet identity, principal ID, and account ID. Always copy and remember this internet identity ID. Next time when you switch device, all this, you need to use back, you need to enter back this ID. It works like your username. So you need to remember it also. So actually, you have an option to store the same internet identity account passkey into multiple devices. You can repeat the process, add passkey to different devices. Or you only have one smart device. If you're afraid that you lost lost your phone, which will lose the passkey, and you will forever unable to log in back this same internet identity. Internet identity also has another recovery method, which using recovery phrase or recovery device. Recovery device means you may need to use something called fido key or whatever. So if you are using recovery phrase, it will create you the same 24 words of seed phrase. Next time, you can use back this seed phrase to recover back your internet identity. But this recovery seed phrase, this 24 words, is not compatible with the seed phrase just now you generated by using DFX. Incompatible. This 24-word seed phrase only for internet identity. So don't confuse and mix up. So next, I just try to roughly introduce network nervous system. Network nervous system is where ICP doing the governance, and it is using the DAO method, Decentralized Autonomous Organization, where most of the decision by using voting all happen under network nervous system. Second, it is also a launch pad for ICP. It also has a default wallet for internet identity. You can use network nervous system, sign in with your internet identity. From there, you can retrieve your principal ID and account ID, and also your ICP token balance and also another synthetic token balance in network nervous system. For those who first time come into this workshop, the first step to start ICP smart contract development, you must understand what is canister and cycle. Canister is a container. It's a container. You can say something like Docker. Before you're able to deploy your smart contract, you need to create a canister. You need to create a canister like you create a house. Once you have the canister, then you will deploy your smart contract, which compile in WebAssembly by code, upload into the canister, then you will able to execute your smart contract. And to run a canister, you need to pay a fee. As in ICP, blockchain is using reverse gas model. Developer required to pay the fee to deploy the canister by using another credit system called cycle. So canister are required to pay for resources they consume, including storage compute. Resources consumption is not paid in ICP token by cycle. Yes, it's another system, another credit system or another token, not ICP. Cycle, we can say it is a stable coin. Cycle, it is a stable coin or stable credit, which 1 trillion cycle always equivalent to $1.32 USD. But ICP is volatile. Cycle is stable, which also easier for developer or project owner to calculate the cost need to pay to run your application in ICP. For end user to interact your smart contract, to send transaction to your smart contract, they don't need to pay any fees. Compared to like Ethereum blockchain, all this for end user, when they want to execute transaction, they need to pay the gas fee. But in ICP, end user do not need to pay any fee because the moment you deploy the canister, you will deposit the cycle into the canister. Any transactions run in the canister or using the occupied the storage or execute the CPU cycle, all this will consume the cycle in the canister. The cycle in the canister will deduct until 0, then blockchain will shut down the canister and your application won't able to run anymore until you top up your cycle into the canister. So this is something different, and it's also a good feature that for developer to onboard the existing web user, because all the web user do not require no need to get ICP or anything to pay to use. They can just come to use without pay any fee. So this is how you start your local network. So just now I will say how you start your local network. So this is how you run a local ICP blockchain in background and clean mode. Then you will use this to create a so-called cycle wallet. In local network, it will automatically deposit with 100 trillion cycle into your local network. All the cycle will store in the cycle wallet by default, and you can check your cycle in your cycle wallet. For mainnet, if you want to deploy your canister smart contract into the mainnet, you need to have cycle and a cycle wallet in your mainnet. How you get? You can using this redeem faucet coupon, whereby later I will share you a feedback form. You fill up with the email, then I will email you the faucet coupon so that you can redeem 10 trillion cycle in your mainnet. Then you can deploy your canisters and your application into ICP mainnet. So you can kickstart your development into mainnet by getting the faucet coupon. For those who don't have the faucet coupon, how do you get your cycle to do your first deployment? This is alternative method. First, you need to make sure the account you created has ICP token. once you have an ICP token, you can run this command line to create the empty canister by converting how many ICP token into cycle. How many ICP token you want to convert into cycle? Example, like this. So once it created successfully the empty canister, then you need to deploy the cycle wallet code into this empty canister so that you will have your cycle wallet ready with the converted cycle from ICP token. This is alternative method. So you already have your cycle wallet ready in the mainnet. Other than that, this is some other useful DFX command like list how many accounts in your device, show current identity, switching different identity, get your ICP token in your account. This is another important command line whereby whenever your canister cycle balance is low, you need to convert your ICP token into cycle by using top up command. So you will say top up with your canister ID and convert how many ICP token into cycle and deposit into your cycle wallet ID or your canister ID. So there are some other references. Okay, so I just quickly run through how you do your first deployment. By using Motoko programming language. In ICP, compared to other blockchain, you not only run your backend function, backend application function, it allows you to deploy your front end or your website into ICP blockchain. That means you can fully make your application on-chain. You will run your website, your front end, example like React, you can deploy in ICP blockchain. And ICP blockchain will expose a web URL for you. This web URL you enter, it will render your website in the browser. Then backend, like other blockchain smart contract, but it has a feature. Once you deploy the backend smart contract, it will expose an API endpoint for your front end to call the API to send transaction to store data in ICP blockchain storage. So this is a first canister you can practice. Start the local. Then you use DFX new hello. This will automatically create a hello world project. So hello world project, two things you need to look into. Choose your backend language. By default, you choose Motoko. Other than that, ICP smart contract language also support Rush programming, TypeScript, and Python. So for front end, there were several options. I believe most of you are familiar with React frameworks. So you just choose React. Because in Web3 developments, a lot of package, a lot of library already has React ready. Second option, you can choose Vue or even Vanilla JS. So once you choose all the options, then a project with folder name hello is created with all the sample code ready. So this is how the ICP DM architecture. If you choose a project with front end and back end, normally when you deploy, ICP will deploy a front end canister and back end canister. Front end canister is the we also call it as an asset canister, where it store all your HTML, CSS, JavaScript, image file, and whenever you call the URL to the front-end canister, it will render your front-end application in the end-user browser. Then you will use the API call the backend function. API will call the backend canister to submit the data, and the data will store in the ICP blockchain storage. So this is how the project structure look like. If you have, when you create project with front end and back end, you will see two workspace. One is back end, another is front end. Front end is all your standard front end code, like React, like Vue. So this is back end, you see .mo because I'm choosing Motoko programming language for my smart contract. Okay, so come to here. It's very simple. Once you have your code ready, you just need to run dfx deploy. You just need to run dfx deploy. dfx deploy will automatically deploy your front end application. It will build and deploy it will build, then create the front end canister and upload all your bundle HTML asset and code into the front end canister. After that, it will also compile the Motoko code, your backend smart contract code, and create a backend canister. So you will see front-end canister and backend canister. So for front-end canister, it has a web URL. It has a web URL. Backend canister, ICP will automatically generate a web interface called Candid interface. It will automatically generate a web interface for you to troubleshoot and test your smart contract. For you to test easier, you do not need to write your own web interface to call your backend canister. You can use Candid interface, which generate automatically. Since without the parameter, dfx deploy actually will deploy in your local network. What if you don't have cycle in the mainnet, but you want to test with mainnet? In ICP has another option called Playground. Playground is a development environment that hosts a canister pool that canister can be deployed to. That means you will have an option to deploy your canister or smart contract into mainnet without paying any cycle, which is Playground. But your canister will only able to run for 20 minutes. After 20 minutes, the canister will be uninstalled and resources borrowed and returned back to a Playground canister pool. So this is an option that you still able to test with mainnet without paying any cycle. You just replace the parameter, put it with -- Playground. So something like that. Okay. To deploy in canister in mainnet, same DFX deploy -- network IC or shortcut -- IC. So once success deploy, it's the same. It will return you a web URL of your front-end canister, something like that, ICP0.io. And another candy interface that you can probably debug or test your backend canister. If you do not want to use candy interface to test, you will able to use another command line to call your backend canister or your smart contract backend function with by CLI, like this DFS canister, this -- network IC mainnet call. I can use my canister ID or canister name. This is canister ID. Your project name is canister name. This is canister name. Canister name. So you also have option by using command line to call your backend function public function. This is how you get your canister ID, get your front-end canister ID, and your back-end canister ID. How to check your canister status? So you just run canister, that's -- level IC status canister ID. It will return something like this. It will return something like this. You look at the status running, means your canister still active. Controller. Controller means that, or you can say administrator of this canister. You should always find your principal ID there. Your account to deploy the canister, by default, it will be the controller. It will be the controller, which means this account has the right to stop the canister, delete the canister, upgrade the canister with a new code. And balance is the cycle balance in the canister. In ICP, paying fee or is prepaid. You need to make sure your canister has enough cycle so that it will keep running. Once the balance go low, become zero, ICP blockchain will shut down your canister. So that then, if this is a flying canister, means no one will able to visit your website. So this is how you get the canister status. When you after you deploy a canister into the mainnet, but you found you do not want your canister running anymore. So this is a command line for you to stop the canister, and you even can delete the canister. Once you delete the canister, whatever remaining cycle balance in the canister will return back into your cycle wallet. The cycle will return to the identity associated with the canister controller principal ID. Yeah, control principal. So you return back to your cycle wallet. So it won't burn your cycle. In ICP smart contract, it also has a unique feature. A canister, you can assume a canister like your device or your smartphone or your laptop. It has RAM, it has hard disk. One canister actually is able to access to 4 gig RAM. RAM, we label it as heap memory, and heap memory is limited to 4 gig. And you have another one, stable memory. Stable memory, you can assume it is like a hard disk, but it can hold up to 400 gig if the subnet can accommodate. So that means a canister like your device with 4 gig RAM and 400 gig hard disk. Why has such feature compared to other blockchain, smart contract, all this? This is something very special. Because just now, I will show you a command. Actually, you can deploy canister, turn on a canister, you can stop and delete. And you can upgrade. So whenever you deploy whenever you build your application, build your smart contract, deploy in ICP, you can upgrade it by default, all this, and you can stop it. So whenever you develop, you need to take care your variable declaration, how you want to store the data. If you store the data in heap memory, when you stop the canister and start again, or during upgrade, all the data stored in the heap memory variable will lose. It's just like you run your application in your operating system. You turn off your application, you shut down your application and turn it on back. All the variable will reset back. But if your variable data declared in stable memory, that means this data is stored in hard disk, like you store in hard disk. The moment you stop it, upgrade, and you start back, you will still have the same data. The data is persist. So when you build your smart contract, you need to focus and look into how you want to store, how your variable declaration, how you want to store the data. Or else, if you wrongly store all the data in heap memory, when the moment you upgrade the canister, you stop and start again, then all the data has a risk of losing. So this is a flow how you upgrade the canister. Start local, generate new project. This is some of the sample code. So this is one example. When you declare a variable with stable, that means this variable will store the data in stable memory. Once you stop and start again, upgrade, the value still persists. So this is how you deploy. Then you have the smart contract you deploy. You use Candy interface to test it. Then you stop it. You change the code. You change the code. You build it. You activate mode upgrade, and you start again and deploy into the canister. Then test again. You will see the backend smart contract is running the new code. By default, all the canister is upgradable compared to other blockchain, which you may need to write your smart contract with upgradable feature. For ICP, you don't need. By default, you can upgrade as simple by running this command line to perform the upgrade. So other than that, ICP also has built-in Oracle services, or what we can call Oracle services, because it has built-in HTTPS out call. It works like AJAX call, or works like the JavaScript fetch means the smart contract can connect to any external web services. So this is an example. So HTTP, I'll call support get, hit, and post. So this is some of the example. HTTP request your web URL. But all the HTTPS I'll call consume cycle. So that's why you need to allocate the cycle and execute the HTTP outcall. Make sure your canister has enough cycle for you to execute HTTP requests. Other than that, ICP also has their own standard, token standard. It has ICRC1, ICRC2 for fungible token. Non-fungible token has ICRC7, ICRC37. So you can find out more. Here. This all ICRC is the canister, is the smart contract. That's why the owner is using principal ID, who own the ICP CRC1, 2 token. The owner is using principal, not the account ID. Later, I will go more in depth into chain fusion. So chain fusions is allow you to since ICP has HTTP outcall, with chain fusion allow you to seamlessly connect to different blockchain. It make it easier for you to build a multi-chain solution and eliminate the need of single trust intermediary as a bridge, because ICP you can consider is built-in trustless bridge for all many type of blockchain. And ICP also has timer, random function. And the best is a threshold signing. Once you connect to other blockchain, you are able to generate the other blockchain wallet address by using their chain key and using the threshold signing to send transaction to other blockchain. Ability of ICP smart contract to sign and submit transaction to other chain. So this is called chain fusion. Later, I will have some sample code to showcase this chain fusion. So what can you do? Trustless cron job service, decentralized borrowing protocol. You can connect the Bitcoin. You can use Bitcoin as collateral, multi-chain asset, decentralized exchange. You can connect to different variant type of EVM chain, Solana chains, all those to cross the asset into ICP and to the other chain. Right now, it's supported more than 21 plus chain and all type of EVM chain. Non-EVM chain is supported like Aptos, Aave, Bitcoin, Cardano, Cosmo, Dogecoin, Filecoin, Toncoin, Tron. So you can find out more in this link. Okay. Let me go to my next slide. We will talk about more about chain fusion. So later I will have a sample. About chain fusion. How do you connect to Ethereum using ICP smart contract? But this time, I'm using Rust language to build the backend canister. You need to get ready your device with Rust language installed. So this is the command line to install the Rust programming language. So once you have the Rust installed, next you can go into this sample code. So later I will explain how my code works. So please fork my code so that you can use it as a reference. So for this sample code, one feature is I create a demo for you to let you create your self-custodian wallet. How you create your own ICP account without using internet identity or any third-party wallet. You just need to using the package of BIP39 and another definitive package called ED25519 key identity. So you can find out the exact code here. So this is one first function that I built in the demo. Second is the Ethereum integration. Showcase the smart contract on ICP can direct interact with Ethereum network and other network that using EVM. So is when send the transaction. So with this integration, it allows you using your ICP account to generate a Ethereum wallet address in the ICP canister or in the ICP smart contract. It will derive a Ethereum wallet address from your ICP principal ID. And in ICP blockchain, by derive their own public key, the CBSA public key, combination with your principal ID, it create a key pair or smart contract has a secret key there or key pair in the smart contract to allow you to sign the Ethereum smart contract transaction. And once the transaction message is signed, and it will use the HTTPS outcall send to any of the Ethereum networks. So this is how it works. So this is HTTP outcall token standard. Okay, let's start explore the codes. Let me see my. Okay. Stop sharing. Share. Something. No. Okay. Okay. Share entire screen. Okay. So, okay, this is the code you can access from this URL. It's the same. So this is a sample wallet. This is a sample wallet. So when we run, you'll come up something like that. It let you to create your ICP wallets. So we built by using React. So it has from here, it has a backend, and this is a front end code. So the backend code has a basic Ethereum. It's the Ethereum smart. It's an ICP smart contract that communicate with Ethereum's network. So DFX is the configuration file. How you want to build your ICP smart contract. So I have one sample smart contract called Who Am I backend using Motoko. This is another sample Ethereum connect to Ethereum smart contract using Rush programming. So that's why I'm using the cargo build to build the codes into the WebAssembly. And it also include another default canister built by Dfinity EVM RPC. This basic canister will use the EVM RPC to transfer the transaction message via EVM RPC and send to the Ethereum testnet. I'm using Ethereum Sequoia testnet to do the test. So this is how the configuration looks like. Okay. And here, so this is the application start. Then the one of the important file you need to look into is this identity file. How you create your self-custody wallets. Okay, create your self-custodian wallets. BIP39 and this one. Okay. Number one, look at the identity. And another one is util. Okay. You see, I'm using the BIP39. So it will generate the mnemonic seed phrase and then convert the seed phrase into principal ID or ICP identity. Yes, you can see. First, this is a function I built from BIP39. It will first okay, let me see now, identity. Okay, here I'm using BIP39 and generate the mnemonic. Then convert the mnemonic into seed. Then from there, using this definitive function generate the ICP identity, which contains the ICP principal ID and secret key. With this, you already have your custodian wallet. With this function, you do not need to have internet identity. You can build your own web wallet or even your browser extension, or even your mobile app for ICP wallet. So the first important function is setup. So this, I pass in a mnemonic, I convert mnemonic to become the ICP internet identity. Then to keep it secure, I encrypt the mnemonic and also with password to store it secretly. Okay, let's try. Okay. So When click the create wallet, you generate the seed phrase, the 24 seed phrase by using the BIP function. Then so waiting. Yes. Created. This is a created the principal ID. And then I have a function to convert to account ID. I have a function to convert into account ID. Let me show you. Because back into the codes. So setup basically will create a identity, the ICP identity with principal ID and the secret key. Then back into dashboards. Okay, here. So how you get your account ID? Yes, here. So I also have a utility function for you to convert, how to convert principal ID into account ID. Because you need to use account ID to receive ICP token. To receive ICP token, you cannot use principal. So I built a utility function. You can look into that. Principal to account identifier. So that's why you can see principal ID and account ID. Later, I will show you how to create the Ethereum address based on principal ID. That means you can use this ICP wallet, ICP account to control the transaction, for Ethereum. Log change to another account. Choose this one. Okay, wait for a while. So right now, I'm calling the smart contract, calling the ICP basic Ethereum smart contract to retrieve my derived Ethereum wallet address stored inside the smart contract, stored inside the ICP smart contract. And this wallet contains the 0.459 Ether in Sepolia. So sending all this just need to use the same ICP wallet. You do not need to create another MetaMask to sign. Basically, this ICP wallet can control any transaction in Ethereum. So let me show your code. Okay, principle, this is very important. Details. Okay, how you let me see how you. So this is very important. Is this file identity? I will create a class. All this, how you create your own ICP account. Then you load it. You can unlock it. You can create it. Then how you integrate your front end with the ICP smart contract, like you are calling the back end, basic Ethereum, how the front end do the integration, and using your own created wallet. Then you can check out this library. You can check out this library. So you need to call this connect function. Let's see. Wallet generate. See? Once wallet set up successfully, or we choose a wallet, now we got the principal. We created an account with principal ID. We get back identity. So this wallet contains the principal ID and the private key. And we attach with, this is a production mainnet endpoint. This is a mainnet endpoint. This is ICP mainnet endpoint. If your local one, it has another local host endpoint. But because this sample I already deployed in mainnet, so straight away connect to mainnet. So this is ICP mainnet. And which wallet I'm using? Just now I already created my ICP account. So I just pass my ICP account and the endpoint. So connect host here. Then this already connected. Then I switch to dashboard. So the dashboard is, so this is a dashboard. So pass the identity and pass the connection in. So for this connection, basically you can use the same connection, connect to different canister, can communicate with different canister. To load the canister for your front end to talk to the canister, all this same like when you call using your front end, call the Ethereum smart contract, like in Ethereum smart contract, when you use Web3.js to call, you also need to include the ABI interface for the smart contract. For ICP, yes, you need something like that. Normally they call it IDL. Normally called IDL. So whenever you build your smart contract, whenever you build your canister compile, normally it will generate, if you are you develop your own smart contract or canister, normally it will generate a IDL file for you. Something like under source declaration, it generate. So this is a basic Ethereum. So it has a DID file for you to include. It's like a ABI. You need this, or else your front end cannot call the canister. So like, so you generate. So sometimes if you don't see, you can use, if you don't see this file generate, you can use the effect generate, then your canister name. It should generate this series of file coming out so that you can include in your front end. You see, I include a declaration, so IDL F3 is an IDL file. We need this so that we can use the connection, talk to the canister. Okay. And you want to get the ICP balance in the account. ICP balance in the account. It has a ICP always built in a system smart contract. System smart contract for you to retrieve the account ICP balance. Account ICP balance. It has a system smart contract called ledger canister. So that's why it's a bit different. So this is I call the token. This is to retrieve this is to connect to ICP ledger canister for you to retrieve the ICP token balance held by this account ID. Here, token. Yes, I didn't pass anything, so it will come into here, so that it will return the object like this. So I will have a get balance function. So by calling this, you will able to retrieve your account ICP balance. So ICP balance is here. ICP balance. Yes. Yep. You can see ICP get balance account ID. I need to convert the principal into account ID so that I able to retrieve the ICP token balance, or else I'm unable. Principal is not used for that. So I got my ICP balance. Okay. Next, who am I canister? How do I bind the connection with who am I canister? How to connect? Well, this is my custom canister, my custom smart contract. So connection, I just do like that. So simple. Connection is here. So canister, I'm using this function. Canister, the canister ID and the IDL file. We build this. So canister ID. Once you deploy, you can check your EMV file. Once you deploy, or you always generate DFX always generate EMV file and return, and in the EMV file return the canister ID. So all the canister ID you should have. So this is my who am I canister ID and who am I the smart contract IDL file. Yeah. So that I will success mine a canister instance, the who am I canister instance, so that I can simply call all the public function. Who am I MO? Let's see. So it has a lot of public function. So all these public function, you're able call call from the front end. Yep. Who am I? So who am I? So who am I? Who am I? So yep, this function. So this function actually call this function, it will return the caller, like your Solidity message.sender. Which account call this function, it will return the caller principal ID. So convert the principal object into its form. See ID. Okay. Principal. Okay. Same. I want to create my instance for my basic Ethereum. This smart contract is connect to the Ethereum Sepolia blockchain. So this is how I deploy the Ethereum, the ICP smart contract connect to Ethereum into the mainnet. So I'm using Sepolia. So I already deploy this smart contract. Then it's the same. So I'm using a basic Ethereum IDL. So now I have an instance of the basic Ethereum canister. So it's very simple. How do I generate the Ethereum wallet address based on my principal ID? Yep, just like that. Ethereum address. It will return me the Ethereum wallet address of my principal ID by using this smart contract. So, okay. Yeah, so you need some time to retrieve and check here. So now it's calling to get the balance. Yep. Okay, update, get the balance. So get the balance is here. So it will return me the if balance is for this address, the if balance for this address. So your updates. So you can see for verify. You can go to Sepolia Etherscan to check. Yep, you can see Sepolia is correct. So to send Ether to another address, using this smart contract function, and how many way you want to send to what address. So signing this transaction basically is also still using my ICP principal secret key. This key sign the message, call the smart contract, then the smart contract will derive another secret key, another private key in the smart contract to sign the Ethereum transaction. So send if. Okay, I can demo you. Okay, send if. Yep, sending. So you just need your ICP wallet, and you can create a wallet for Ethereum's EVM blockchain, Solana blockchain, all this just with one ICP wallet. So this is so-called chain fusion. Wait for a while. Okay. Let's see. Transaction. Yeah, maybe the gas fee. Okay. Wait. Okay. Right. Obtaining wait. Okay. So this is all the public function, exposed by the smart contract. So for the chain fusion technology, by using chain fusion, all this, you were able to access more function by using Rush to write your smart contract. So this is a sample. So you can refer to it. So the library that you need to include, IC Ethereum types. There is some of the library you need, the IC CDK, development toolkits in Rust. So in default, it will be loading the, if you know Rust, lib is the entry point. Lib is the entry point. Okay, done. Send ready. You can see the transaction hash. Yeah, I retrieve the transaction hash. Yes. You can see the transaction hash. The transaction hash returned from the smart contract. Yep. So that means you can see I'm using my ICP wallet to send Ethereum transaction, sending 0.02. Nice, right? Yeah, so you update all this. Okay, so these are some of the sample of the Ethereum, how you send the Ethereum transaction using chain fusion. There's a lib, init. When the smart contract start, update. This is the Ethereum address. How to use how to convert your principal ID into Ethereum address. Yeah, you use this Ethereum wallet new. So Ethereum wallet new, the class is here. New. Yeah, it convert the principal using derived public key. They are using two keys. One is using your principal ID and another public key, another ECDSA key, decentralized key stored in the ICP blockchain. So it used both data to derive. Then you get a derived public key. From there, it will convert this derived public key into Ethereum address. And when you want to sign the transaction, this is a signing ECDS transaction code. So how do you derive the path and the derived key and calling this is the ICP system canister. We are using ICP system canister to sign the transaction. So once we sign, then after that we will send. You see the send. So first we check, not, we already log in a principal ID. We already log in an account. If it's not account, if not log in, then we will reject. Send to which address? Chain. We send to Sepolia. Nonce, we get a nonce. Okay, come to here. Signature. Yes, you see. Sign. We generate a transaction data, transaction hash, then we sign. Then we get the transaction with signing signature. Then from there, we convert into the transaction and we use the EVM RPC. That means the EVM RPC canister to send the Ethereum raw transaction. Those transactions are already signed. So this is how the flow of this sample code. So you may need to also refer to this sample code when you do development if you participate in hackathon, if you want to provide a multi-chain solution. Yep, this is one of the sample code that you can refer to, how you build the cross-chain, how you cross the asset from Ethereum into ICP to create a digital twin version of your asset. You can refer to this code. You can refer to this code, study this code, how they use the threshold signing, because this is a sample of threshold signing, and the EVM RPC canister to submit a transaction to Ethereum blockchain. But because the sample is in Rust programming, so you may need to learn something about Rust programming. Right now, Motoko cannot do one feature. That means Motoko cannot call EVM smart contract. Cannot call EVM smart contract. Back to the site. Okay. Let's see. Sign in. Okay. So you can go to this link to understand and study further. Signing message in Motoko in Rust. But in Motoko, just like I already say, they got one disadvantage. They cannot call EVM smart contract if you using Motoko to write. So that's why if you want to enjoy the full feature, you need to use Rust programming to write your backend canister. So this is some of the sample code that you can refer. You can clone my codes and test it. So at least you know how to integrate your front end and back end with your own wallets. I think come to here now is this another link where you can search, you can find a lot of the Ethereum project in ICP. And you also can check out this one, Ethereum canister. Is a Ethereum like client canister in ICP. You may need to refer to this code also, whereby it help a lot on how you integrate with Ethereum in ICP. And also this OIC wallet is also a multi-chain wallet. Okay, so far I think these are my today sections. If you have any questions, please do let me know. Please, you can leave your message in Telegrams. You can leave your message in Telegram. I will try to look into that. And those who want the free cycle coupon, please do let me know. Later, I will share a feedback form. All this, please sign up. Please fill up the feedback form with your email. I will send you the free cycle coupon later. Then you can test your development into mainnet. Okay. So any questions up to now? So far, okay? Am I too fast? Or okay. So I think Broxbot, you can take over this conversation. My section will be end here.
Thanks, Francis, for the session. Guys, if you have any questions or need free ICP coupons, you can join the Telegram group and we can reply you over there as well. If you have any questions, you can drop in the chat box.
Okay. Thank you, everyone.
Thank you, Francis.
Yeah, hope to see you next section again.
Yeah, in the next session.
Yeah. Okay, bye, everyone.